Dear participants, I would like to invite the second invited speaker, Paulius Kozlovas.
Morning.
Morning.
You can see me, you can hear me?
Yes, everything is fine.
Awesome, great. All right, let me share the screen in a second. Let's go ahead. Let me know if you can see it full screen.
Yeah, exactly. Everything.
Perfect. Great. Shall I start?
Yeah. Please.
Okay. All right. Good morning, everybody. My name is Paulius Kozlovas. I'm on two chairs at the moment. I mean, literally, I'm on one right now, but professionally, I'm on two chairs. One is a third-year PhD student at Kaunas University Technology, and the second is head of technology development at Ignitis Group. For those who don't know, Ignitis is a large energy utility in the Baltics, and certainly my interest in energy when it comes to PhD correlates greatly with the content that Ignitis is interested as well. So today, my idea was to give you a glimpse of the view we have in terms of energy ecosystem vision for the Baltic Sea region, including Latvia and Estonia. And I've seen some people joining from Latvia, if I'm not mistaken. So hopefully you will find some interesting points. This is not a strategy of the company or something that we're about to go to execute. It's more of a idea how the region could look like given the terms and needs that we have to meet. So that's very shortly about it, and I'll hope to make it within the next 20 minutes. So let's go ahead. So first thing that we have to consider when it comes to developing any sort of vision for energy in Europe, and especially East Europe, Baltic states, we have to understand that there are regions of oversupply and overdemand. So it happens that theoretically we are in oversupply region, even though all Baltic states are importing energy. They are net importers rather than exporters. Lithuania among the greatest imports in EU when it comes to the ratio. We import roughly around 66% of energy yearly. That's certainly not a good thing. We have to change that. But looking at this graph, this map, certainly we can see that Baltics, they do have a great potential to become an energy exporters. And then the Central Europe is in a over demand, right? So in the long term, they will be importers of energy. Because if we will continue the path to decarbonize, electrify multiple sectors, that will require a lot of electricity, a lot of energy. And certainly those regions, they do not have capabilities theoretically to maintain themselves. So that's one thing, right? So, secondly, as a note, we have to understand that importing energy, as Europe is largely doing now through LNG carriers, when it comes to, for example, other materials like hydrogen, that's very difficult to do because the boil-off rates, if you're familiar with them, they're very, very high when it comes to hydrogen. So that means that you will be losing from 1 to 3% of energy a day just because of boil-off effect. So that suggests that the countries that even have a shoreline and the ones that are in over-demand, they will not be able to import something else besides gas, right? Besides natural gas, because hydrogen economy suggests that would be very difficult. So we know already that we're in oversupply. We have Central Europe that will be in overdemand, and we know that Central Europe will have problems importing energy with carriers if it will be carried in a form of hydrogen, which was actually speculated for some time that this could be the case. So Europe, obviously, European Commission saw this as an issue that for decarbonization, which actually Central Europe is contributing the most when it comes to carbon emissions. And if Europe is ready to take that action, that we need a source to supply green energy from somewhere. We know the gas and the East file is definitely not a long-term strategy anymore. We do understand that importing gas from other regions is also some sort of dependency on the regions that might take advantage of us at some point in the future. So we need something produced locally, something that we can rely on, and that's why the European hydrogen backbone was developed as an idea, with one goal really, to evacuate large amounts of power from north, which has an oversupply of green energy, to southern Central European countries. This idea is another factor that we have to consider when we are drawing a vision for the Baltic states. And this backbone basically says that there are two options to evacuate the power. Evacuating those amounts in the shape of electrons would be rather expensive and difficult to do, and it gets increasingly easier if we're talking about converting electrons into molecules, so essentially hydrogen or other synthetic fuels. And then there are two ways to do that: is either onshore pipes or subsea pipes. So that's a big study done. It's I think more than a year and a half old now, but it's starting circulating in the region, and the operators of gas transmission infrastructure, they're certainly now looking into how this could be done. So that's another thing that we have to understand, that those plans are being drawn, and our really interest is to understand how do we play in such an environment, right? And then the third aspect, right? So oversupply over demand, that's one thing. There are plans for evacuating the power, and then yet we're not self-sufficient itself, right? The Baltic states are still importing the energy. So what do we export, right? And well, when we look at the potentials in the region, that's where we're going to start to soon realize that there is a massive gap between our current plans when it comes to renewable energy and the potential that we have. But there is a catch, and that catch, I think you're very well aware of, and my PhD interest is exactly in this area, is how do we develop a system that can accommodate large quantities of renewables by still maintaining the financial interest to invest, because mostly the focus is on technical aspects, saying we can connect 4 gigs of wind onshore, we can connect 5 gigs offshore, etc., etc. So it's all about technical flows and the physics. And I get it, it's very important. But more than that, what is the most important really is to motivate the investors to do that, because the connection is only one thing. The second thing is what you're going to do with it. Are you going to make your investments return? And from the modeling that me and my team been doing, we found a rather uncomfortable truth that if Baltic states, including Lithuania, Latvia, Estonia, if altogether we install more than 2.4 gigs of offshore and 4 gigawatts of onshore, everything beyond that will become very little attractive or even hard to bank or finance because of the revenue issues, because of saturation, because of price cannibalization. So on one hand, we are talking about we have a lot of potential, we have relatively good grid, still lots of power to be connected. I don't know if you're aware, but for example, in Lithuania, it's something like 7 gigs are estimated, like 7 gigs are available to be connected until 2030, massive capacities. Yet our modeling shows that you can connect, yes, but you probably will not make a lot of money out of it. And investors are certainly know how to calculate that. So how do we maintain the investments going into renewables? That's the main question of this vision and potential solutions that could be helping to address the challenge. This maybe was a little bit for less experienced energy audience. I believe here I don't really need much to explain that, but just to maybe remind that the problem of the revenue is that once you achieve some sort of saturation levels of renewables in the grid, basically because of intermittency, because of those generators, either solar or wind, they generate more or less at the same time in the entire region, you have prices plummeting to zero or negative even. And in Lithuania, that's been a case now almost every weekend on a low demand period and a sunny day. We had, for example, 8 hours of negative prices, 8 hours in the market. So if you have a solar, if you're commercially operating solar power plant, basically a lot of energy that is being produced in that plant is zero value, because there is simply just not enough demand to take that power for some sort of money. So what happens then? The question is, how do we really lift the renewables if the rest oversupply is already there? In some days we already have this moment when we generate really more than we need and more than we can evacuate through the cables or pump storage power plants, etc., etc. And obviously, because of intermittency, then still we highly rely on imports, and that's not a good thing. So how do we address that? So the only way to really lift that generation, to keep investing, right? Because those two yellow graphs, they're really just to visualize that, if we want to increase the gigawatts connected in the grid, we have to address the main challenge. And the main challenge is the oversupply. How do we ensure that the investors will be paid for the energy that exceeds the natural demand? Because if they're not getting paid, certainly their business case is going to become very weak. We have seen in Great Britain last year, 7-8% of wind energy was not produced. It could have been produced, but it was not because of zero or negative prices. So that means that when you're calculating the yields of your generator, you have to consider that factor, obviously, because even though you're not going to generate simply because the energy is zero value. So we have to address that challenge. And I'm afraid that in the Baltic states, we're going to have a situation where probably very soon, in 2-3 years, actually it's already starting happening now, it's getting harder and harder to finance the projects if their starting day is 3 or 4 years from now. Because the banks, obviously, with their analytics, they can see that this is going to become a big challenge, and that it's only maybe half of your energy. Let's put it in just an example. Half of your energy is going to be valuable, and the rest of the half is just going to be unnecessary. So how do we solve that? And who has to really address that challenge? Because the problem is national, the problem is regional. We are importers, we're dependent. And I mean, nuclear, we heard, maybe let's build nuclear. Okay, fine, but that's 15 years from now. So what do we do in the meantime? We have to address this thing. And I'm afraid that I think the states themselves will have to address this challenge, saying we will build an infrastructure that can take this excess energy and convert it into some sort of other products, ensuring that the investors will maintain some sort of economy behind their plans. If not, then we will saturate the market within 2-3 years, and those nice plans to have lots of gigawatts connected to the grid might never come into reality. So what does that flexible demand could look like? Well, in theory, obviously, we're talking mostly P2X, and that's the main topic really in Europe. I can share just maybe a personal insight. There is a Wind Europe, a big conference every year happening, and it's all about wind. But actually, this year was kind of very different year, because there was an increasing number of people talking about not about how to generate really electricity, what was the most efficient way for a wind farm to operate, but really what to do with that energy in the hours that nobody needs it. So the main answers are producing molecules, typically hydrogen. We say that, well, hydrogen is great, but it's only a part of a story, right? Because if hydrogen, you can produce many more synthetic fuels. I'll talk about that a little bit later. But so the idea is that if there's a lot of flexible demand, if there is in instruments and infrastructure in the region that can absorb a lot of energy for long hours, right? Because as we know, wind is not, it might be windy for a week or two. So in 3 hours, in the first 3 windy hours, our batteries are full. Our pump storage power plant, which has a great capacity, it's full in 6 hours. And then what do we do with the rest of the period, right? So the rest of the period, at least now, seems like the only viable solution is a flexible P2X demand that can kick in and take a lot of energy from the grid. How does that look on the map? Again, that's a vision. It's not like some sort of investment plan, but again, how could that look like? So as we know that we have a pretty unique infrastructure. I'll show a slide about that. We have a big power plant with a grid connection, and it's kind of become decommissioned in 7-8 years. So Elektrėnai, which is the power plant, potentially seems to be a good place for such infrastructure that could absorb a lot of excess energy and to maintain some sort of returns for the renewable investors, because that's the most important part is to continue building the renewables. Otherwise, we will never become nearly close up to self-sufficient unless we build, I don't know, nuclear or something. But that would mean that in 15 years, we have no solution. So we say that if Elektrėnai could develop, if there would be a development in Elektrėnai for Power-to-X, that could continue fostering the investments in renewables, at least onshore, right? Because I don't know if you're aware, but Elektrėnai is really at the heart of the energy system, at least in Lithuania. It has 6 power lines, 330 kV power lines coming into one single spot, which means you can evacuate a lot of energy from onshore connections. And basically, what we are trying to say is that if we, as a country, want a lot of renewables being installed, that's a strategy at the moment. It's not enough just to find the connections. We have to find a means, an infrastructure to be built to maintain the energy need, the flexible energy need on the on the periods where renewables are very working on a maximum load. But that's one part of the story. The second part of the story is a lot of that potential that we saw on the backbone, the plan of evacuating the power from the north. A lot of that power is being estimated to be generated offshore, right? So onshore is one thing, but then what do we do with offshore? With offshore, there is another challenge that you do have 2 problems in offshore. First, you just simply cannot physically connect all the potential onshore. So that means that from offshore, you can connect maybe 10% of the potential, and then the rest, well, you have to do something with it. If you want to extract that potential, you need a means. So, for example, what Danish are doing, and very likely that Baltics would also would need to look into it, is to develop some sort of energy island, which would be a intermediate, which would be the in between the shoreline and the parks, making sure that a lot of power can be evacuated from the wind farms offshore and converted into some sort of molecules. Then, later on can be exported to West Europe, to those high demand regions. That's at least the theory. Where's the energy island? How it would look like? Maybe it could be onshore, but just not connected to the grid. I mean, that's technical details. We're not really. That's very long perspective, so I don't think that is really worth to dig into. But if we want to address and saying Baltic states should become energy independent, well, these are some sort of level of infrastructure that we have to be talking about. Obviously, we do in Lithuania, for those who are not from here, we have two largest hydrogen consumers in the Baltic states, and actually in more than that, it's a very significant consumers region-wise. We have the largest fertilizer company. They are the largest gas consumer in Lithuania. Just to put in perspective, they consume around 60% of gas, natural gas, and most of those gases are being used just to generate and produce hydrogen, which is needed for the end product. Certainly, if we want to decarbonize that sector, there's just no other way. You need hydrogen, and if hydrogen is not from natural gas, then the other way is from electrolysis. So certainly, that infrastructure around renewables would benefit Lithuania in particular greatly, because that would help to decarbonize those two companies that contribute vastly to the emissions, right? And then here's the backbone, right? When we said, like, so how do we play in that system? How do we see Lithuania and the region in terms of developing the backbone? So the backbone is certainly this one of the options is subsea, to evacuate the power from Finland and Baltic states. And certainly we say that if Baltic states will be sleeping, well, Finnish guys, even though they're being made fun of being not the fastest in the region, but actually when it comes to infrastructure projects, except nuclear, that took 20 years. But they will develop some sort of agreements with Germany and supply energy to them directly. And then the question for Baltic states will be, what do we do then? How do we join that trade? How do we, join the pipe? What's the process? So we say, ideally, if Baltic states come together, we could maybe be the first region to connect through the subsea of Baltic Sea, subsea connection for hydrogen from Baltic states to Germany, making sure that the rest of the infrastructure will be built later, and that we are not really on the side of it, but we are certainly going, that the infrastructure is certainly going through us, and that we're one of the exporters as well. Without that massive of a plan, it's very hard to then believe into renewables continue developing in the region, because certainly there's just no economics behind that beyond certain level. Just a few slides, maybe just to summarize those ideas that me and my team been investigating for quite some time. So basically, energy island, some sort of, it's a very broad term. There's a visualization of Danish energy island. Again, it could be built onshore, offshore. It really depends on a specific location. So, but the really main point is that 2.4 gigs offshore in the Baltic states seem to be a reasonable number to connect that much of a power to the grid, integrated to the grid, and evacuate the energy from offshore. But if we are looking into potential, which was identified into a number of studies, the potential is 10 times greater. And without energy island, looking at that potential would be certainly very difficult to talk about it. So we just want to put exclamation mark saying it's great to have a lot of potential, but if we want to have it all, and if we're talking about potential as something that we want to take advantage of, we have to be talking some sort of big solutions. Otherwise, that just doesn't work, right? So that's a little bit of that. That's a glimpse of Elektrėnai. It's a well-known object, really nothing new here, but certainly just, I guess, the significance of the power plant was never maybe seen in such an importance. But if we would look at this as an opportunity to convert this legacy gas power plant into synthetic fuels hub. Certainly the infrastructure is just unbelievable, right? We have gigawatts of power. Certainly some of the power is still being reserved for the units here, but as we know, Elektrėnai is 75% of the power plant. 6 out of 8 units are decommissioned. So this whole area is already empty. We have 2 more units that will operate maybe for the next 7 8, 10 years, who knows, but certainly not for a very long time. So this entire infrastructure is just going to be there. And most importantly, there's this distribution infrastructure. I mean, it's not really a distribution grid; it's a transmission grid, but it's a massive six lines, accumulated for accounts for 3 gigs something. So we're really at the heart of it. And certainly, if we would be talking about infrastructure there, we couldn't think of a better location. Obviously, technologies are at a very early stage. It certainly will require lots of step-by-step moves in that direction. But my idea is that if there is no such a signal from big players in the energy market saying that we're at least thinking about it, the investors of renewables will certainly stop their investments very soon, and then there will be a very hard and very difficult to again incentivize and start the process again. And the products, again, I'll show you maybe the graph. Again, I prepared it kind of for a broader audience, just to understand a little bit better. So when we're talking e-fuels, everybody's saying the price is ridiculous, it's really expensive, and they're right. At the moment, it is a very expensive solution. It's not really viable today. But if we model the market with 2 or 3 times as much renewables, we can see that half of the time the energy will cost less than 20 euros megawatt hour. And I mean, now we have 5% of the prices, 5% of the time, the energy that cheap. But with every megawatt installed, the price, the number of hours, the cheap hours a year is increasing. So when you start working with those kind of numbers, then that doesn't look that bad. And so certainly the e-fuel concept is that, well, you take the excess energy, you convert it into hydrogen, and then you can use it already in, for example, fertilizer production. I put it as an example, the company in Lithuania, but again, if you have an export line, you can export it, you can push it directly to the end consumer. So it's really flexible. How do you do it? But that's the best business case, obviously, because those fertilizer companies, they do need hydrogen, and there's nothing else they can do about it if they want to maintain the production. That's the need. However, if you do not have an end consumer close by and export is limited, well, when blending hydrogen with CO2, then you can convert synthetic fuels, which are very, very stable in terms of storage. And the 2 most popular options are methanol and synthetic methane. The good thing about them is really that you can store that for a pretty long time. So, for example, when it comes to synthetic methane, well, the formula is basically the same as natural gas, CH4, which means that you can really push that those renewable gases into the grid, even use Andriukaitis. For the ones that doesn't know, I mean, it's the largest gas storage in Baltic states, right, in Latvia. So you can even produce gas, technically speaking. The price of that gas really depends on 2 main factors: is that electricity needed for electrolysis, and then the price of CO2. And those both things move in the direction that benefits the synthetic fuel idea. And then those fuels, we can have multiple ways to utilize it. I mean, methanol and synthetic methane, they're well-known materials, well-known fuels. It can be generated back into electricity through generators or fuel ferries, or I don't know if you know, but Maersk is the largest carrier, the carrier operator, cargo carrier operator, and they already are signing contracts in the ports for 200,000 tons of methanol being produced for their carriers, for their ships. So it's happening. I mean, it's not an idea. And certainly, if you want to move on, you can capture nitrogen from ambient and produce ammonia. Ammonia has, again, quite few use cases. And as an example, again, if you have a fertilizer company next by, that could be interesting for them, just as an idea. Another thing, we're going to an end slowly. Another thing is just that here on the left, there are assumptions that what the governments are claiming they want to have in 2030, and those are gigawatts of renewables, right? Solar, offshore, onshore, hydro, and we just did some mathematics and modeling, but basically saying if we're talking about the need for flexibility in Baltics, and we put some limitations, right? So one limitation is that we do not want to curtail any energy. So that means that we want to produce all the time, all the energy available, which is a little bit on the dramatic side, but let's put that just to put in the perspective. So if we say this is what we want to generate whenever it's possible. Every windmill wants to operate at any time. And another thing is, and then the other limitation is that we do not know, and we cannot prognose 100% the renewables, right? It's what's happening now, so you're never really gonna know exactly the generating capacities forecasts for another day. So combining those two needs of flexibility in the grid, the need is dramatically high. Only with the numbers for 2030, and that's what you were saying. Like, just think about that. Those 0.32 terawatt hours is including the largest pump storage power plant in the Baltic states, right? And then if we want to have those numbers with zero curtailment, that would be up to 9 terawatt hours of flexible energy that grid could take or give. And certainly curtailment is okay, not generating for some hours, it's okay. So this number obviously in reality could be certainly much lower, but that doesn't change the fact that we're talking times, not like 20, 30, 50%, but we're talking 3, 4, 5 times more flexibility needed for those kinds of amounts. And we just did quick math again on what the idea could look like with Elektrėnai. So just to give an perspective and numbers, if there is 1 gig of power of electrolysis in Elektrėnai working flexibly, that's very important. So that means that it doesn't generate hydrogen all the time. It generates only during the hours when there's over capacity in the grid, which let's say roughly could be half of a time. This could give you 5 terawatt hours of energy. So I mean, there's 1 gig, it's 5 hours. If you have 500 megs of electrolysis working flexibly, that can give you 2.5 terawatt hours of flexibility, it's a great number. So we just try to maybe highlight here the importance of really addressing that challenge, that 10 meg of electrolysis or 20 megawatts of electrolysis is not going to really be very significant. You have to talk hundreds of megs. If you do not talk about that, then those numbers 2030 here, well, it's more of a nice dream. And just maybe the last and probably one most important thing, that P2X is a nice idea, but obviously the most important thing for it is for the energy system to be running at lower costs than without the P2X, right? So P2X should have a positive impact on the energy total price, yearly. And in theory, and I mean in practice, really, again, this is only to visualize it, but when you have a surplus renewable energy, and again, if you are looking at Nord Pool prices, I do believe you do check up from time to time, you can see that on the weekends, on a sunny days, especially if there's a little bit of wind, the prices are going negative. That's happening already, which was unheard, by the way. 2 years ago, having negative prices in Lithuania was just never heard of it. So that's happening, and it will happen more and longer, and the changes is happening already. And then when you don't have generation, the prices are going pretty high because the gas generators have to kick in. If there is no wind, no solar, well, imports plus gas. That's pretty much it, and that's an issue. With P2X, in theory, you definitely levelize that. So you do not have as many negative hours. We have to understand that. So for some, it could look like, so I'm not going to have negative hours. I will pay more for electricity. Yes, you will pay a little bit more than you would pay without the P2X. But then that energy can be actually converted into other storage into molecules that could give you energy back into the grid for potentially more reasonable price that you can get from the connectors or from the gas power plant. Again, it all depends on geopolitics, agreements between the countries, etc., etc. But in theory, the largest problem of renewables is that without P2X, there will be a lot of energy not produced at all. It will just never be generated. So if you, and we have that energy. I mean, we have wind, we have sun, but without these instruments, we're just not going to take advantage of that fully. And certainly the price of kilowatt hour produced will increase because, well, some of the time you're just simply not going to work. So the expectation is the price to be lower on average with P2X rather than without. And to give you arguments for that, now we are in progress of massive study to look into it in details, because just to give you an understanding, I mean, Nord Pool prices, the result of it is impacted by 80 different factors, all right? So there's a lot of moving parts that predefines the energy price. So P2X coming into game, we have to look into that very holistically. But obviously, if that doesn't make sense, then this idea is rubbish. But the problem is that and me personally, I cannot think of any alternative in the short term. How do we become at least 70% net generators? And I know that without these things, renewables will not going to come into, not going to reach really the levels to supply a 70% energy. So I will ask you to maybe suggest and share what you think about that. So my takeaways on this vision and how do I contemplate this problem of our region is that flexible demand is a key component to maintain the investments going on into renewables. If there are no claims about flexibility developments in the region, we will soon have investments in renewables slowing down. And that's going to hurt us because we will lock ourselves up, I assume, around 45% in Lithuania case, 45% self-sufficient and end of story, which would certainly is not a great position to be for a long time. Another thing is that we have to understand that green hydrogen produced from electricity is the only sustainable way to cope with current CO2 emissions that are contributed and comes from gray hydrogen production. So if we want to decarbonize refineries, fertilizer productions, there's just no other way, even in theory. So this is something we have to really understand, that if EU decides to take that path, delivers funds for that, green hydrogen is the only way. Regional agreements are extremely vital. As you can see, the map involves a lot of countries, a lot of different ideas, and that has to be talked about on the highest level. Really important to have a vision with your neighbors. And I mean, looking at the past, that doesn't look very promising. We know how LNG terminal happened, and how much neighbors wanted to contribute. With the nuclear power plant was also challenged. So I think that those regional agreements are going to be very difficult to reach. But if we don't manage them, hydrogen economy becomes very difficult to have, because I mean the pipe really benefits when it goes through as many consumers and as many producers possible. And flexibly produced synthetic fuels is currently, my knowledge, is kind of the only viable solution for a long-term energy storage, because as I said, batteries and pump storages is only a day, solves a problem during the day. Volatility, but if the volatility is 2 weeks of a period of oversupply, then there's just simply no way how to evacuate that power and to keep making the economy working for the investors. So that's it. I'll happily take some questions if we have time for that. I try to not take too much time. Please react if there's anything to.
Okay, thank you for the presentation and for the clarification about the situation in our region. And may I ask you, do we have any questions from the audience? We have one question in chat.
I'll open it so I can read it then for everyone. The comments, it says, thanks for the informative presentation. Are there practical obstacles in the stage of power to hydrogen, in your opinion, to reach the goals that have been set for the future? If yes, what are those obstacles? Efficiency of the equipment, other issues. So basically, I would say so. The main really challenge is to maintain the interest of the investors to keep investing in renewables, which will result in many hours for a low energy price. If we do not have at least 40% of hours below 20 euros megawatt hour, hydrogen economy then just simply doesn't work, because it is not an efficient process. Only half of the energy that you take from the grid will be converted into hydrogen, and then more processes involved, then you lose more energy thermally, etc., and economy doesn't work. But if you take the energy at a very low cost, nearly zero, then it does make sense. So I would say there's a lot of developments going on. Ignitis itself has invested in few companies through Ignitis Innovation Fund that actually specializes on making the electrolyzers more efficient. So there's certainly going to be an increase in efficiency of production, but nevertheless, it's never going to be 100. It's never probably going to be a 90. But even with 70 or 80% efficiency, we still have to understand that we need that excess energy in the first place. And what I'm trying to say is that I think it has to come at the same time, a promise to develop flexible demand, and then investors saying, okay, I hear your message, you will take my excess energy, so I will keep making some sort of money and I'll keep investing in renewables. But if we don't do that, then without the excess energy, then all the story is just worthless. And I just wasted half a year of my time.
Okay, thank you. And I have one question, if nobody would like to ask more. What about the demand of energy in our country and our region? Let's say what was 5 years ago, and what are the trend and what you foresee trend for next 5 years? Is it going up significantly, or it is maybe stable right now?
Amazing question, Darius. I love this topic because it really changes the calculations and modeling immensely. I've seen estimates for 2050 in Lithuania. I've seen estimates from 80 terawatt hours to 19. That's the gap of forecast. Currently, we have 12 and a half, right? 10 years ago, we had 12 or like 11 and a half. So the increase in the demand in reality is pretty low. It's yearly 2%, 3%, something like that. Lots of expect that, with fertilizers decarbonizing, with other sectors decarbonizing, that if you substitute that energy in the shape of gas, in the shape of oil products, if you substitute electricity, you might end up in 60, 70 terawatt hours. Personally, I'm very on the conservative side, how much more the demand will grow. I assume for 2030, we would be looking maybe at 14 and a half, 15 terawatt hours in 2030. From 2050, I don't forecast. That's something you can do in sauna, but not here. So I don't forecast that. But 2030, I think we will have increased, but nothing too dramatic. And then, and that is on the low side with many forecasts that we have. That's still on the low side. So I'm a little bit afraid that we try to fix the business case, and like I'm talking about like regionally, we try to fix it by just saying the demand will be huge and everything is going to work out. I think we will not have a growth exponentially until 2040 or at some point, but certainly not within the next 6-7 years. It just doesn't sound realistic. That's my personal take.
I see. Okay. Thank you. Okay, so now we will have the lunch, and we will meet after 1 hour.
Okay. Thank you. Have a great day.
Okay. Thank you. Bye.